day, viewer. This is the group for Denver Maburutse and Jabulo Mazibuku. This is for WP Work Package 5. For this practical, we decided that Jabulo will do the code and also contribute to the presentation document. Denver will be the one to present and to help through the code as well, to debug and make it as workable as possible. We both designed the circuit separately since we are staying at different places. So as you are looking at the diagram here, this is the hardware implementation. We connected the ADC to the temperature sensor with the connected wires as follows, with the ground there. As our temperature sensor has 3 pins, the third one is the one which is actually connected to ground. And the one in the middle, which is the output, is going to the ADC. And VDD, which is 5 volts, will go to the 5 volts output of the Raspberry Pi. The LDR is connected to the ground and to a pin to the ADC. Let's go to the flowchart of how our program is working. So as Python, you know, it runs through the main method by equating name equal to main. Then we set up the Raspberry Pi so that it takes the SPI protocol. Then it goes to the chip select setup. It makes the object creation using MCP. And there's also the GPI pin setup, which also adds on to the callbacks. So it then prints the headers that will appear on our screen. And with the infinite while loop, it will start creating various threads, which are indicated as a fork here. So these threads, they'll all work in parallel, but I made the program continue on this side because of space limitations. So I'll go through thread 1 as if all the other threads are also going to do the same thing. So thread 1 is going to start, and then it converts raw ADC to degrees Celsius using a function, which I'll show with on my Python code. So as this changes to degrees Celsius, this program will also listen to any button presses. So initially our button press is 1, which will give us a time interval of 1 second. Other than that, if you press it once, it will give you 5 seconds. If you press it twice, it will give you 10 seconds. So that is only the difference in which ones it's going to print. Because as the different threads join each other, they'll print the actual values of the converted temperatures. So yes, that's the block diagram. The parts where it affects the hardware part is mostly the setup, where to set up the protocol and also set up the pins to see if it's an input or an output of the Raspberry Pi. I would then show you how this is actually affecting with a live video. This is a screen recording, so I'll add on a live video that will demonstrate how the LDR is affecting the values and how when we press a button, it's actually changing the time intervals. So without further ado, let me run the code. So if I say python adc.py, it starts to go through 1 second, and our LDR is recording 0 with a minimal because at the moment it's all in the darkness. So once I put on a torchlight, you will see that the values will start to increase, showing the change in temperature. If I remove the light again, goes back to 0. setup of the hardware. And as you can see, as the time is going by, it's going by every 1 second. So if you press a button, it should be able to change this time interval. As you can see, it's now 5 seconds. If you press again, it should increase to 10. Because I had pressed it before, it should record the 10th